Yeah, dear students, in this video, we talk about what are the activities we will do as part of laboratory work for this computer network subject. In this computer network lab, our syllabus is scattered into two parts. That is, one part will give you the implementations of all responsibilities of different layers of the network, like data link layer and physical layer, network layer, transport. Likewise, every layer is having some set of functionalities. Those functionalities we are trying to implement in this first part of the laboratory work. And second part, we talk about the simulations of computer network with the help of simulation tools like NS2. This way, our computer network syllabus is scattered into two different units. This slide will show you the different functionalities of layers and its implementation experiment list. So this is I covered with the part 1 of the laboratory, and in part 2 we make use of some traffic monitoring tools like Wireshark to observe the packet flow between different nodes of the network, and similarly we make use of NS2 simulator in order to identify how many packets are dropped in the middle and how many packets are successfully delivered with the help of TCP UDP, and its comparisons and its results. All these things are done with the help of NS2 simulator. And now get into first experiment of this computer networks lab, that is framing concept, which is one of the responsibility of the data link layer. So the framing means when data is sent from one node to another node, the data has to be rounded into a unit called as a frame. When data is rounded into a unit, we must know where the data is beginning and where the data is ending. That we call it as a boundaries of the units. So taking the data and putting the boundaries for the given data in order to make up a frame is called as a framing. We will take the data from a unit and we try to create a frame by adding header and trailer. If you add header and trailer to that data, then it becomes a frame. So this process we call it as a framing. Now this framing can be done in two ways. One is with the help of, if the data is sent like a bytes, like characters, then you can implement this framing with the help of character framing. Or if the data is sent like zeros and ones, and that framing concept can be implemented with the help of bit framing. So while preparing this framing concept, there is a problem of these flags, what we call like a header and trailer, may appear as part of the data. If header and trailer are appear as part of the data, then the system will think that the data is not properly prepared because the frames are appeared as part of the data. So let us get into this stuffing so that you can understand how this stuffing concept is helpful us to avoid the problems what we will face. Yeah. Let us look into this bit stuffing concept. Now, the concept of bit stuffing is when data is coming from the above layer like zeros and ones, we want to prepare it like a unit. That preparation we call it as a framing. As part of framing, what we will do is we will add a header like where that frame is beginning and where that frame is ending. So that is indicated with the help of flags. That is indicated with the help of flags. Now, the problem here is flag also represented with a code call it as 0 followed by 6 ones and 0, that we call it as a flag. I repeat, so let me take an annotation now. So if it is your data, this we call it as data. Now what we are trying to do is we are trying to add a frame. This frame is prepared by adding two flags which will indicate start of the frame and end of the frame. This flag is internally indicated with 0 followed by 6 ones, 0 followed by 6 ones and 0. This is the notation of the flag, and similarly here also. Now, the problem here is if this data itself contains the 6 ones. So, if you observe here, here we got some 6 ones and here also we got 5 ones. Likewise, the data itself, if the data itself contains this pattern, then this total data may not be considered. Maybe if this pattern appears at this moment, let us say here that pattern is appeared, then up to this part only the data is considered and passed to the above layer, but this is not the end of the frame and it is part of the data. Actually we have end here. So in order to differentiate flag which is appeared as part of the data, there should be a procedure to avoid this problem. Okay, let me clear all these things. So now what they are trying to do is in bit stuffing, whenever we come across 5 ones in the data, in order to avoid it from the flag which is indicating with 0 followed by 6 ones. So in order to avoid the confusion which is data and which is flag, we trying to insert a 0 after 5 consecutive ones, so that no flag pattern is appeared as part of the data. No flag pattern is appeared as part of the data. That's what they did in this example, that we call it as a bit stuffing. So additional zeros are added in order to differentiate the flag from the data content. Now this additional zeros are not part of our data. These are added in order to avoid the problem, but this should be removed at the end of the receiver. At the end of the receiver, the process of removing the added zeros is called as a unstuffing or destuffing. Okay, so destuffing is done very simple. Whenever we come across 5 ones, that followed 0 has to be removed. That followed 0 has to be removed. So if you observe here in this method, so here we got totally 3 and 4, totally 7 ones are there as part of our algorithm, that is bit stuffing concern. Whenever we come across 5, whenever we come across 5 ones, a 0 has to be added. So after counting 5 ones, a 0 is added, so that we have avoided that 6 ones pattern, 6 ones pattern which is considered to be flag. Similarly 1 0 is added. So if you observe here also, here also we got 5 ones. Whenever we come across 5 ones, one additional 0 is added, that we call it as a stuffing work. So this way a frame is prepared by adding flags at the beginning and ending, and in order to avoid a confusion whether this flag may appear as part of the data, in order to avoid this one, additional zeros are added. The rule for adding additional zeros is whenever we come across 5 ones, one additional 0 is added, so that a flag never happens as part of, appears as part of the data. This way this is prepared at the sender side. Whenever it is received at receiver side, the job of the receiver is to remove the zeros which are added, that is not part of the data. So in order to remove these zeros at receiver side, at receiver side, so this way the added zeros has to be removed at the receiver. That process we call it as a unstuffing. So that how that receiver will remove that added zeros, mean the formula is very simple. Whenever it come across 5 ones, it will remove the 0. So here, and it counts 5 ones, it removes the 0, and after removing the zeros it is going to collect its data back. This is the data which is sent at the sender side. This way we can come across a problem of uh, this stuff concept, call it as differentiation between a flag and a flag appears as part of the data. So let us look into the procedural work, that is when we want to make up a program. So we'll try to observe what are the different steps we require, and later we'll convert that one into diagrammatic representation. Then we try to get into coding part. So let me clear all these things now. So this is the concept. So if you observe clearly from the above work, what we are trying to do is we try to read the data from the above layer. Whenever you come across 5 bits in the 5 bits in the string, then 1 0 has to be added. 1 0 has to be added. Likewise, these 3 and 4 steps are continued till the end of the input. We give a bigger input. So what we try to do is we take we check that 5 bits. If it is 5 ones, add the 0, and then again take 5 next 5 bits, and if it is again 5 ones, add the 0. This process has to be done till the end, so that zeros are stuffed into the data. Okay. This is a step by step procedure, call it as an algorithm. And if you observe this diagrammatic representation of our work, that is stuffing concept, bit stuffing is implemented like this. Upon start, we read a string from the user, that we call it as zeros and ones data. Once that is taken, what we do is we trace 5 bits in that string. If 5 bits are all ones, stuff 10 after it, and this process has to be done till end of the string, till you come across end of the string. Once you come across end of the string, that entire string what we have done, like by stuffing the zeros at this step, is printed, which is going to give you the stuffed contents by adding additional zeros to the data. That's what we are going to print at the end. So this experiment is going to implement bit stuffing concept, where original data is taken. Try to observe, is there any pattern which is similar to the flag? If it is so, additional zeros are added. By adding additional zeros, we prepare a data that we call it as a stuffed data. That's what we are going to print at the end of this program. Okay, right. So let us look into this program part. Now, if you observe this program, so let me partition this program with this slider. Yeah. So now here, what we do is we try to take the input. We try to take the input by taking a string that we call it as input. Now, after taking the string, we have fs, which is indicated like a frame sequence. Frame sequence means flag. Always flag pattern is 0 followed by 6 ones and 0. This is the flag pattern. That flag pattern is set into fs. Now, we have a job of stuffing whenever you have a input string of more than 5 or equal to 5. If your input string itself less than 5, there is no concept of stuffing at all. That's the reason we stop our work if the input is less than 5 length, because there is no way of doing this stuffing work if you are having a string of less than 5. That's the reason what they are trying to do is simply your given data is concatenated with the frame sequence is concatenated, and then here at the end, so this is closing of this else. Here at the end again one more frame sequence is added to that fs, so that you prepare your data, that is a, by appending fs here and fs here at the end. So adding this fs is done with this code, and adding with this fs is done with this line. So that is first part. If your data, that is a, is your data is having a length of less than 5, right? So then, for example, you have a string which is more than that. In that cases, what we try to do is we try to scan that entire string. And if you have a string, we don't want to scan this one till the end, because we always search for a 5-bit pattern, so that last 4 bits no need to be considered, because we need 5. We need 5. So up to this place only you are able to get a pattern of 5. So you have to scan from this place to this. That will indicate the boundaries on which we are working. That's the reason I is beginning with 0 and ending with length minus 1, length minus 4. So this way the boundaries are set. Once set, once boundaries are set, so here in this step, what we are trying to do is we are trying to take a 5-bit pattern. So I, if it is I 0, 0 to 5, so a 5-bit pattern is taken into temporary variable called t and added with null in order to make it as a string. It is t is a string now by adding this null character at the end. Once you got that t, what we try to do is you got 5-bit pattern. What is our job? Whether it is equivalent to 5 ones or not. We need to check whether it is equivalent to 5 ones or not. In this step, we try to check the taken temporary sequence of 5 bits is compared with 5 ones. If it is 0 means we need to stuff. So 0 indicates means whatever the sequence we have taken from the input and is equal to 6 ones, 5 ones. If both are equal, then we are having a job of stuffing 1 0, stuffing 1 0. So that's what they are trying to do with the help of a string handling function, called it as string concat. The frame sequence is taken, which is copied with 5 ones followed by 0, 5 ones followed by 0. Then and we start scanning again from here. That is the reason j is moving a step back wherever that I is stopped. So if I is stopped at 5, again we start from this location. That's the reason it is going back for next iteration. Once this is done, okay, if it is not equal to 5 ones, then what we will do is we simply move on to the next character. We simply move on to the next character by taking a temporary variable r is copied with a of I, which is the last character whatever we have taken here. I is the last character, and then r of 1 is set to null, indicating that a pattern is taken and that is not once, and that is added to the result, and that result here is fs is the result. Okay, r is added to fs. So this way, if it is equal to 5 ones, a 0 is stuffed, and if it is not, then whatever we have taken from a, that is copied into fs, which is a result here, which is a result here. And then that entire result is copied, into a temporary variable, that is t here, temporary variable t, and p is the indicator, p is acting like an index. So what we do is, whatever you got in a now, as of now, that is copied into t, and that t is at the end set with null, and that t is copied to frame sequence, this way this work is done. Once it is done, at the end one more frame sequence is added, and it is going to print the result. So here basically, if you see in this entire method, here this we call it as input section, defining frame sequence, early part. So every data should be preceded with this number, and every data should be followed by this number. That's the reason first and last steps, if you observe, this pattern is added, and later this part will check whether your given string is a file length less than 5 or more than 5. If it is less than 5, you don't have any work, just copy that one into the result and then print the result. If it is not, if it is more than 5, then we need to take out a pattern, that is 5-bit length pattern is taken from the input, that is compared with triple ones. If it is so, stuff the data. Once data is stuffed, we will go back to this and copy the entire remaining content to the result. And if it is not equal to 5 ones, then simply that content whatever we have taken as part of this input, that is simply added to the result. So this way this entire program is trying to implement the concept of bit stuffing. Okay, let us see this result also. Let me show the execution also. If you observe this program from the editor, now this part of the program is working for taking the input, and this is to set the first flag, that is beginning flag for the data. This is to check whether the data is having file length or not, and if it is not, if it is more than 5, then we will take 5-bit pattern and compare it with 5 ones. If it is 5 ones, one additional 0 is added, and if it is not, then simply the content is copied to the result, and finally the remaining content is copied into the result, because we have not scanned that input string totally. So if you observe this for loop, here we have scanned that input, last 4 bits are not scanned, so this last 4 bits we need to get back. That you can do with the help of this for loop. Once you got your data into t, make it as a string by adding the null character at the end, and after that this t is added to fs, which is a frame sequence. so that you got total data which is stuffed. Okay, let us run this one for the sake of understanding. So see this screen. When I run this, yeah, compiling the program. If you observe, so it is asking for a string. So now for example, I got a string which is not having 5 ones at all, let us say 4 ones string. Now simply what happens is, it is preceded with a flag which is 0 followed by 6 ones followed by 0, and it is followed with the same content, and your content is pushed in the middle. So there is no clash with flags. Your data is not having a pattern which is having a clash with the pattern. When it is having a clash means whenever it is having a 5 ones. Okay. So let us run this again. So now what I do is, I take a data of 6 ones. Now the job of this bit stuffing is, whenever you come across 5 ones in the pattern data, a 0 has to be inserted, that is one work, and this entire pattern should be preceded and followed with what, a flag. So now when you run this program, see this, preceded with a flag, followed with a flag, and later on in your data, whenever you come across 5 ones, one additional 0 is added. Whenever we come across 5 ones, one additional 0 is added, and remaining part is copied here, it is not left. So this way, when we have a 5 1 content in the data, there a additional 0 is added. This additional 0 adding process, we call it as a bit stuffing. It is working for any number of ones in the input. Now this example is only one unit with 5 ones. Okay, let us take one more time where we got multiple patterns with this content, like let us say 0 followed by 5 or 6 ones, whatever it may be, and after some time again I have 5 ones. This is, so now the data becomes like this. So first 8 bits you leave for flag, and last 8 bits are for flag, and now after this here we got 6 ones. So after 5 ones, one 0 is added, that you can understand, and here also after 5 ones, one additional 0 is added. After 5 ones, one additional 0 is added. Okay, this way the stuffing concept is implemented. Okay, so let me show that slide for the sake of understanding. The output is like this. When you give an input, if that input consisting of a 5 1 5 ones pattern, definitely that should be preceded by 0. So this is your data, and in this data your data should be preceded and followed with flag, that's okay, flag, and in the middle whenever you come across 5 ones, it should be placed with 0, that's in the green color. After 5 ones, one 0 is inserted, and after that you got your 1 back. Similarly, it is one more input where you got a couple of 5 ones. So here you got 5 ones, here we got 5 ones. So your entire data is preceded with these flags, okay, which is in red color, flags, and after that in the data whenever you come across 5 ones, a 0 is added. It is 5 ones, right? So after 5 ones, one 0 is added, and this 0 is part of the data, is taken here, and again here it is normal 4 ones, no need to consider, 4 ones followed by 0 is taken as it is, and where stuffing is taken place means here we got 5 ones. So after 5 ones, one additional 0 is added. This way additional bits are added into the data. So this is end of this bit stuffing concept.